All right, guys, in this video, we are going to cover inverse functions. This is still part of section 1.5. If you missed out on the first lesson, we did parametric functions, so definitely go check out that video. But here in part B, we are covering inverse functions. So what you see on your screen is some of the notes for it. And inverse relation is just a relation that consists of all ordered pairs BA, for which AB is in relation R. Okay, so a lot of times what you're going to see with these inverse things is just switching your X and Y. I don't know if you notice that the order changes, right? So with inverses, that's what you're going to see a lot of. If F is 1-to-1, that means it's going to pass the vertical and the horizontal line test. So if we want to know if something is a function or not, just in general, you just check for the vertical line test. But if you want to know that it's going to be 1-to-1, meaning that both a function and its inverse, they're both functions, right? It would need to pass the vertical and the horizontal line test in order for you to verify that. All right, then we have a little bit more down here. It says if f is a 1-to-1 function with domain D and range R, then the inverse function, we denote it with that little -1 exponent, okay, but we read it as f inverse. That is the function with the domain R in the range D. So again, what happens is the x and y's switch, okay? If originally it was domain D and range R, the inverse switches those, domain R and range D. You're seeing this notation in here, but again, the biggest thing when you're trying to find a inverse function is you're going to swap the x and the y, and then work your equation for that, okay? So for this first example that y'all are seeing here, and if you write kind of large, you may want to try to go to another page to write example 2. This may or may not be enough space for you, depending on if you can squish your writing. So I would give yourself a little bit more space maybe than what I gave. But on example 2, they said we're going to write an equation for f inverse of x if f of x equals x over x plus 1. Wow, that's a lot of x's. Okay, so to work this one out, what I'm going to do first of all, okay, remember that f of x is the exact same thing as y. So if it helps, feel free to rewrite it like this first. You don't have to. You can kind of get away without it. But I think this helps sometimes to see, replace that. So when you decide to find a inverse function, what you need to do is basically just switch your x and y's. That's what we want. So I'm going to swap, and everywhere that there was an x, I'm going to put a y instead. And then everywhere that there is a y, I'm going to put an x. So switch, I'll make x, and then this is y over y plus 1, just like that. All right, now I can't leave it this way. We still want to write it in terms of y equals. So I need to go through and rearrange this so that it says y equals, not x equals. Okay, so the first thing I would do is you have to get y out of the denominator, okay? And there's only one trick to really do that, which is to multiply by that denominator. We're going to multiply by y plus 1, okay? But if I do that on one side, you have to do it on the other side. Ooh, there we go, y plus 1. So it cancels on the right side, okay? But you still have this y plus 1 times x equals y. All right. Remember, I'm still trying to get y entirely by itself. So it's kind of tricky because we've got a y over here and we've got a y stuck inside the parentheses. So here's what we're going to need to do. We need to distribute this x through the parentheses. So let's do that. If I do that, we end up with xy plus x equals y. All right, let's put our y's on the same side. So I'm going to subtract that xy from both sides. If you subtract an xy on both sides, that ends up saying that x equals y minus xy. You notice how these both have a y? All right, So they both have a y, which means I can factor out a y. I'm going to bring this up here just so that you can see the whole problem at once. But if I factor out a y, this is going to be x equals, factor out a y, 1 minus x. All right, almost there. Remember, I'm still trying to get y by itself. Well, right now, y is being multiplied by 1 minus x. In order to get y by itself, divide by 1 minus x so that that goes away. And that leaves me with y all by itself on one side. On the other side, x over 1 minus x. Okay, so I'm going to say y equals x over 1 minus x. All right, and that works. So there are different ways to like vary this because a lot of times people love to see the x first. They also like to see, I don't know, they always like to see all kinds of things. So you could see this maybe written a slightly different way. It's possible that people would switch the x and the 1 and make it a negative x plus 1. And they can rearrange it all kinds of different ways. But I think that this is probably the simplest. Okay, there's our answer. They said, what's the function? There it is, y equals x over 1 minus x. Okay, all right. Next thing, let's talk about inverse composition rule. Remember how we talked about composite functions back in section 1.4? This is going to use those composite functions to help me figure out the inverses. Okay, so this question, or what this rule says, is they said a function f, I've got too many f's on here, a function f, okay, is one-to-one with inverse g if and only if the following things happen. F of g of x equals x, and g of f of x equals x. Okay, so watch what happens. It's pretty cool. Get my paper. So when I do f of g of x for this problem down here, we're just checking to see if this was an inverse function or not. Okay, and in order to check, we need to check f of g of x, and then we need to check g of f of x. All right, so look first. F of g of x, right? Remember, that's me taking g and plugging it into f. If you've forgotten about composite functions, go back and watch the 1.4 lesson, okay? So I'm going to plug g into the f function. That means everywhere there's an x here, I'm going to replace it with the g function, the cubed root of x minus 1. That's going to be cubed and then plus 1. Okay? Well, when you cube a cube root, they cancel out. So really, this is just x minus 1, but then we still have this plus 1. Negative 1 plus 1 cancels and makes just an x. So f of g of x equaled x. Now let's look at the other one. What about g of f of x? Plug f into g. So everywhere we're starting out with the g function, which was a cubed root. Everywhere you see an x, put f of x instead. So everywhere I see x, I'm going to put x cubed plus 1. Right? Then I have the minus 1 at the end. Well, look at this. We have the cubed root of x cubed. 1 minus 1 is just nothing. So just the cubed root of x cubed. The cube root and the cube cancel and leave you with x. So f of g of x equaled x. G of f of x equaled x. That means f and g are inverses. Okay? All right, one more question, guys, and then we are done. So look here, example 4. They said show that this function has an inverse. Let me zoom out a little. And they said, and then find a rule for f inverse of x and state the domain restrictions. So we are going to show that inverse. We're going to show how you would get that inverse function and what that would be. and then state the domain of it. Okay? So remember that your first step when you're finding the inverse is to swap your x and y. So make that little note to yourself. Swap x and y. So if I originally have y equals the square root of x plus 3, we're swapping x and y. So it's x equals the square root of y plus 3, just like that. And then to solve it, you're going to have to go through your algebra, but I need to get rid of the square root. So do the opposite and square each side. If you square each side, that cancels out and leaves you with x squared equals y plus 3. One more step, subtract 3 over, and that gets you y by itself. That is my inverse. F inverse of x is x squared minus 3. Now to state the domain needs to match the domain of the original. So match domain of f of x. Okay? That's what we need to look out for. So they said state the domain restrictions. The domain restrictions of the parent function or the original function are going to also be in place here. So because that was a square root function, you've got to think about what's going to cause this to be negative. That would be if x was less than negative 3. Negative 3 is okay because if you plugged in a negative 3 plus 3 is 0. The square root of 0 is 0. The problem is if I plug in a number smaller, like a negative 4, then you would end up with a negative under your radical, and that's not okay. What I need is my domain to give me real answers, okay? Which means I need all my values to be negative 3 or more. So we're going to say either you can write it like inequality, x is greater than or equal to negative 3, or you could write it as a interval notation, which would be negative 3 to infinity. Either notation, I'm fine with either one, okay? You don't need them both. Just pick one you like better and go with that. There's our function, our inverse, and there's our domain. All right, guys, that is it for this section 1.5. Again, if you missed the parametric function one, make sure that you go back and check that lesson video for part A, and that way you don't miss it. All right, I'll see you later. Bye.